project we're working on is with our partners Qatar Petroleum and Shell to study one of the most pressing problems facing us globally, and that is the capture of carbon dioxide and the storage and underground reservoirs to prevent global warming and climate change. And we're building on a previous collaboration with Shell that was looking at different sorts of reservoirs and coal seams for the storage of the CO2. This time we're looking at the reservoirs that are very common in the Middle East, carbonate reservoirs, which are less studied and more difficult to actually store the CO2 in them. The significance for the Department of Science and Engineering is that it really exploits two major areas. One is the experience of the geology of carbonate rocks that they have in the department, and also the world-class reservoir engineering expertise that enables us to model the processes that we're going to study. And we've been able to appoint two new people in these fields that have reinforced strategically the staff in the department.
Our role, we collaborate of course with the Department of Chemical Engineering, but our role is threefold in this project. The first is to understand the geology of the huge carbonate reservoirs that you see in the Middle East that contain a large fraction of the world's oil and gas, but are also potential storage locations for CO2. So we have one large project on understanding that geology. The second is our contribution to understanding the behaviour of CO2, CO2 brine, subsurface mixtures of those fluids. Our particular emphasis is on how those fluids move and the coupling of that movement with the reaction and how you then use it for safe storage. And then the third plank is to put all our experimental information into numerical models. We make measurements on small pieces of rock, but the field sites are going to be many kilometres across. And the only way of understanding and designing injection at that scale is through numerical modelling. And as a consequence, under this programme, we're developing novel numerical tools to study this. So under the three main projects, the first is understanding the carbonate geology of the Middle East with particular reference to Qatar. That has two strands. The first is field work. We have a number of our researchers now doing field work, looking at rocks that are similar to the rocks deep underground in Qatar. Interestingly enough, those rocks deep underground are above the surface in Oman, neighbouring country, so we're studying those rocks in Oman. The second, back in the lab, is to use advanced mass spectrometry techniques to make very, very sensitive measurements of the composition of these rocks that tell us about the past history. And it's very exciting. We're the only lab in Europe who's able to do this. And we're the second lab in the world, and we're the only lab that's applying this to oil field and gas field problems. The second is our contribution to the experimental programme looking at fluid flow in rock samples, and we have an extensive programme looking at fluid flow coupled to reactive transport. And then the third aspect is taking what we measure in the lab into numerical models and developing novel numerical techniques that enable us to input information at the small scale, at the scale of our laboratory samples, and make predictions of flow at the scale of kilometres for the design of storage and for enhanced hydrocarbon recovery.